All right, Honors Algebra 2 and Algebra 2. This is your Monday, October 25th for Honors Algebra 2, or Wednesday, October 27th, notes video. This is in the Matrix packet. It is this one. I've emailed all classes, and it says exactly that. Now, I might say, well, no, it does say this. So, put fall 2019 and beyond. Chapter 3, Part 2, Game Plan, The Matrix. Make sure you write your name. Getting you plenty of time to print that out. So please do that. We are looking at first page 1 right there. Now, if you don't have a printout, write it on a separate sheet of paper, but you will be turning in the game plan like this. So you have plenty of time. You got Honors Algebra 2. I'll actually finish it this last week that I'm gone. So you need to print this out at school or at home this week. You can do it. All right, so we're back here. This is page 1 in a matrix. It's an array of numbers. Kind of think about your Google Sheets there or Excel. You type things in matrices all the time, all right? And they are just essential in linear algebra and programming. Really, really cool. And so we're going to do operations with the matrices. That's a plural of matrix. So we'll talk more about them as well when I get back. There's an entire course in college that talks about matrices, linear algebra. All right, linear programming gets into it a little bit as well. I think I mentioned that class before. So a lot of fields utilizing matrices for us right now, an array of numbers. So give the dimensions of each matrix. So this is the first one. Again, you can see it on yours. And dimensions are row by column. Row by column. Now, what's a row? This is a row. Column, that should be easy. Think about columns on homes. They go up and down. All right, so this is a 1 row, 2 row by 1, 2, 3 column. 2 by 3. This is a 1, 2, 3 row by 2 column, a 3 by 2. This is a 1, 2, 3, 4, 5 row by 1 column, 5 by 1. And this is a 1, 2 by 1, 2, 3, 4, 5, 2 by 5. Now, everybody, what is 2 times 5? 2 times 5 is 10. You have 10 numbers in there. 2 times 3 is 6. There's 6 numbers in there. 3 times 2 is 6. There's 6 numbers in there. 5 times 1 is 5. There's 5 numbers in there. Remember, row by column. All right, perform the indicated operations if you can. If not, write impossible. I've abbreviated some of this, all right, but I'm looking at mine as well. So first off, what do you think -7 would go with? It is the first row, first column. Well, it's going to go with the first row, first column of this next one. So the resultants matrix by answer would be -1. How about the 3? The 3 is going to go with the -9 to give you -6. And lastly, this 8 goes with -11 to give you -3. That's my answer. That matrix, which is a 1 by 3. Now there's an issue with 6. First off, all right, 7 can go with -12. -1 can go with with 7. Then 3 is all by itself. They don't have the same dimensions. You have to have the same dimensions to add and subtract matrices, so 6 is not possible. 7, these are very interesting and important. These are square matrices. A square matrix, just like a square has a same length and the width. Try to adjust my foot here. A square that we think of, geometric square, so does a square matrix. 2 rows, 2 columns, 2 by 2. So 6 plus -7 is a -1. This is the first row, second column. -3 plus 10 is 7. -9 plus 8 is a -1. And finally, 4 plus a -4 is 0. That's my answer. On 8, I've got this matrix, which is a 2 by 3 matrix that I'm going to multiply by 4. Multiply every single element, that is a number inside, like first row, first column, elements. A number inside of a matrix there. It's called an element. I multiply them all by 4. All right, 9 is just like 7. I can subtract 6 minus a -5 is 11. -3 minus 7 is a -10. 2 minus -4 is 6. 8 minus 2 is 6. Okay, we're not going to rest them like that. What comes next? Number 10. So, ooh, look at this one. So negative 4, I'm going to multiply everything in this matrix by negative 4, which I've done right there. And I'm going to multiply everything, don't worry about that plus, I'm going to multiply everything in this matrix by 6, which I've done there. And now I'm adding the two matrices. Negative 28 plus 48 is 20. Negative 12 plus a negative 24 is a negative 36. 24 plus a negative 18 is 6. 8 plus a negative 42 is a negative 34. All right. (14). 11 through 14, that is. Take a look here at perform the indicated operations. Now I have changed it. If you look at your page number 2, as a negative 3/4 yes on the outside, but I'm changing this second row, first column number to a 16. Change that to a 16. All right, so everything in here is going to be multiplied by negative 3/4. 12, negative 12, and a negative 6. Plus, everything in here is going to be multiplied by 2/3. Doubled, then divided by 3. Doubled, then divided by 3. All right? And now I can add the two matrices together. 2 by 2 and a 2 by 2 is going to give me a what? 2 by 2. Negative 9 plus 14 is 5. 12 and 12 gives you 24. Negative 12 and negative 6 is a negative 18. Negative 6 and negative 8 is a negative 14. That is my answer. Let's take a look here at number 12. Now, the first 3 by 1 matrix gets everything's multiplied by 6. The second 3 by 1 matrix, everything is multiplied by 3. Now, don't worry about this negative 4. If you multiply everything by negative 4, then you have to put plus. So instead, I'm just going to multiply everything in that matrix by 4 and just keep the minus sign there. That's no big deal. All right, so 42 plus a negative 12 is 30. 30 minus 4 is a 26. 0 plus 6 is 6. 6 minus 0 is 6. Negative 6 plus a negative 9 is a negative 15. Minus a negative 4 is a negative 11. All right. Let's take a look at 13. Oh boy, 13 has 6 times the sum of the two matrices. So let's add those two matrices together. Negative 3 plus 5 is 2. 2 plus a negative 4 is a negative 2. Negative 1 plus 1 is 1. 1 plus a negative 1 is 0. Now everything inside that matrix gets multiplied by 6. Okay, so today we don't need the graphing calculators. Tomorrow, though, we'll grab it with the graphing calculator, start class tomorrow. And about midway through the video, I'm going to show you the first thing we're going to do with the graphing calculators. All right, because it has a matrix button. Second x to the negative first. Second x to the negative first. On the TI-84s, that is, when I hit second x to the negative first, on the TI-30 XS multiview, nothing happens. It just says like answer. So, nope, nope. Let's go to 14. 14, negative 7 times this matrix plus 8 times this matrix. Multiply everything in this matrix by negative 7, plus multiply everything in that matrix by 8. 42 plus a negative 8, 34. 0 plus 16, negative 28 plus a negative 40. There you go. All right. For A plus 2B, can this happen? A and B are both 2 by 2 matrices, so yes it can. So what I've done is, there's matrix A, I multiplied everything in it by 4. Again, make sure you're showing this exact work. We'll have plenty of time, both classes go over the test review before you guys do this matrix test. This is the second part, and it is maybe the easiest test of the whole year. Then I'm going to double everything in B. Matrix B, I doubled everything. All right, now I'm going to add them together. 0 plus 18 is 18. Negative 20 plus a negative 10 is a negative 30. Negative 24 plus a negative 4 is a negative 28. And 56 plus a negative 32 is 24. There's my answer. All right, 16 doesn't have much work. Just take everything in D and multiply it by a negative 4. Negative 4 times negative 2 is 8. Negative 4 times negative 6 is 24. Negative 4 times 0 is 0. You guys get the point. Same thing, 17 is very easy. Take everything in B and multiply it by negative 3, which is what I've done there. All right, so then to finish off this, I'm going to take everything in C and double it, plus everything in D, multiply it by 4. Every element in C, every number in C, multiply it by 2. Every number in D, multiply it by 4. Now I can combine them. 16 plus negative 8 is 8. 4 plus negative 24 is negative 20. Negative 8 plus 0 is a negative 8. 2 plus negative 10, 12 is a negative 10. Negative 18 plus 68 is 50. 26 plus a negative 4 is 22. That should be it. All right, moving on. B minus A. I wrote B first, minus A. 9 minus 0, just corresponding. Negative 5 minus a negative 5, 0. Negative 2 minus a negative 6, 4. Negative 16 minus 14, yes, is a negative 30. 2D minus C. Take D and double it. Everything in D gets doubled, minus C. Negative 4 minus 8 is a negative 12. Negative 12 minus 2 is a negative 14. 0 minus a negative 4 is 4. Negative 6 minus 1 is a negative 7. 34 minus a negative 9 is 43. Negative 2 minus 13 is a negative 15. And that is it for page 2, 1 and 2. That is that first section. Now, we are not going to go to the next section yet. Instead, you can pause this if you need to right now. We're going to make a jump to page 9. Page 9. They should be numbered pretty well for you. Page 9. I'm going to get there eventually. That's not page 9. That's page 8. Page 9 looks like finest quality in Augmented videos. Looks like that. It says Augmented Matrices at the top. Numbers 1 through 4. Write an Augmented Matrix for the following systems. What is an Augmented Matrix? So there's the system. Here's what an Augmented Matrix is. First off, you have 3 variables. So you got 1, 2, 3 columns here. Second off, you have 3 equations. 1, 2, 3. So I've got 1, 2, 3 rows. But I'm going to have a dot, dot, dot. This dotted line kind of stands for equals there. And on the right side of the dotted line, I'm going to have my constants, 1, 12, negative 1. And a 2 goes in here for 2x in the first equation, followed by a 1y in the first equation, followed by a 1z in the first equation. Dot, 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 which equals 1. 3x plus 2y plus 3z equals 12. 4x plus 1y plus 2z equals a negative 1. All right. Those are very easy to write. Number 2, write the augmented matrix here. And in some classes, they do row reduction, linear algebra, that linear programming class. You'll also do the same thing, do some operations. We'll use the calculator for that this year. So this time I only have x and y. So 1, 2, dot, dot, dot. My constants of negative 4 and 13. I just have 2 rows because I have 2 equations. 3x plus 2y equals a negative 4. 4x plus 7y equals 13. All my variables have been positive thus far, so let's take a look at one whether or not. Again, I have 3 equations, 1, 2, 3 rows, and I have 3 variables, 1, 2, 3, and then dot, dot, dot. My answers of negative 4, 10, negative 2, those constants, what each equation is set equal to. You know, this left side is set equal to, that is. 6x minus 4y. Make sure you have a negative 4. That's the biggest mistake that I see in a few days when we start typing things into the calculator. Make sure you have a negative 4. Positive 2z equals a negative 4. 2x minus 2y plus 6z is 10. 2x plus 2y plus 2z is equal to negative 2. And I switched the, I don't know, it might have been a number 1. I switched the order. Yeah, because it said 2z plus 3y. So I said 2y plus 3z. So switch that. That was a number 1. Oh ho ho, be careful here on number 4. On number 4, I have 5x minus 5y plus 5z is 10. 5x, negative 5y, 5z, 10. 5x minus 5z is 5. Something is missing. The y is missing. 5x, 0y, negative 5z is equal to 5. 0x, 5y, 10z equals 0. All right. Now I'm going backwards. Given the augmented matrix, write the system. So first off, see this dot, 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 and it's just got 2 equations. And before the dot, 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 it just had 2 columns, so that is x and y. 2x plus y equals 6. 6x minus 2y equals 0. Do not solve. Do not solve. Though if you solve that, you're going to get x is 1.2. So we don't want that. Do not solve. Just write the system. All right, so I have 3 equations, and before the dots, I have 1, 2, 3 columns. So x, y, and z. 6x plus 5y plus 2z is a negative 1. Negative x plus 3y plus 7z is 12. 5x minus 7y minus 3z is a negative 52. That's page 9. All right, we're going to finish this up here with... Go to page 10. Page 10, the very next page. So you can put data into matrix. Now I made a misprint here. It's not 2 by 4, but 4 row by 2 columns. But anyway, that's SAT data from the turn of the century. All right. Verbal math. Now I think it's what? Reading math, right? So write 2 4 by 2 matrices to represent the mean of verbal and math scores. All right, so here we go. First one is going to be verbal, male, female. You're just going to put, just going to rewrite these numbers. All right, and that is a 1, 2, 3, 4 by 2. 4 by 2. It's got to be a 4 by something. It's 4 years. So I made a typo. And then here's math, 2001, 02, 03. Male, female. B is find the combined SAT score. How you find your combined SAT score is you take your verbal and add it to your math, and you get that. Take 504, add it to 498, get that. 509 plus 533, boom. 502 plus 498, boom, and so forth. This plus this gives me this. This plus this gives me this. This plus this gives me this. This plus this, you guessed it, gives me this. All right. And we are going to finish today's notes with example 1. Just add the 2 matrices together. It just gives you a fact on the bottom there. Add these 2 together. Negative 7 plus negative 3 is a negative 10. 0 plus negative 1 is a negative 1. 2 plus a negative 3 is a negative 1. 6 plus 8 is 14. Negative 3 plus 2 is a negative 1. Negative 4 plus 11 is 7. And correspondum, 3 by 2 plus 3 by 2 is a 3 by 2. Negative 10 plus a negative 4 is a negative 14. 18 plus 3 is a 21. Negative 2 plus 8 is 6. 7 plus a negative 5 is 2. Negative 3 plus a negative 2 is a negative 5. And 9 plus 2 is 11. And folks, I think that is good for either Monday or Wednesday, depending on which class you are in. Again, I'm getting ahead of these videos, so I have plenty of time to be checking those view counts, and I have a lot of time to add questions, if need be, to certain exams. So the ball's in your court, folks. Make sure you're watching this. Make sure you're watching this. Remember, we still have Hapara. We still have that. All right? Look forward to seeing you guys very soon. This is Yak Math Videos signing out.